My name is Eveline Wandl-Vogt, and it is my honor and pleasure to introduce you to our lecture, which is called Digging into a Sea of Knowledge. We hold this lecture together, namely Elian Carsenat from NAMSOR in France, Dario Rodighiero from MetaLab at Harvard and MIT Comparative Media Studies in the US, and myself, Eveline Wandl-Vogt, from the Austrian Academy of Sciences and as Electronica Research Institute Knowledge for Humanity, both in Austria. We are holding this at a Pixel Conference 2020, and we are very much delighted to talk with you about digging into a sea of knowledge related to COVID-19 and our related findings. Our work is mainly based on the idea of fostering humanity-centered design and work towards a more inclusive, sustainable technology. If you are looking into the current situation, and especially related to the pandemics, we see that it affects the life of nearly everybody who is living on that planet, which is extensive. We are looking into how we can deal with it, how we can deal with this crisis, but much more seeing and interpreting COVID-19 as an accelerator that is changing our life, and everybody has to deal with how will it affect his or her life, and who do you want to be in this crisis during COVID-19 and probably afterwards, or in the world afterwards and the new normal, how we call it very often. At Exploration Space at the Austrian Academy of Sciences, as well as the Knowledge for Humanity Research Institute, we are very much looking into growing and learning together and in a participatory approach. If we do so, we have to go through a fear zone. And that's actually the same if you are looking into COVID-19, which is just accelerating this process. The three of us decided we want to learn and grow and still want to go together through these uncertainties together. So we decided we want to make our talents and our knowledge available for those in need, and wanted to think of what and how we could apply it to things that are currently probably necessary or needed most. This brought us into thinking about a joint project together. Actually, with both Elian and Dario, I'm working for quite some time. But during COVID-19 lockdown 1 in Austria, starting this year in February, March, we were starting this project in a more operative way. And both of you will tell you now about their work, about their concrete visualizations to focus on what we are doing so far, especially on related to visualizations. This is the visualization. Dario will introduce the cartography of COVID-19 scholars, and then Elian will follow with the Chinese Z and related to the Artivive app. And finally, we will have a Q&A where we are discussing, and we are open for your questions and hope to get you on board and get insights and more information from you. Thank you so much, and looking forward to the presentation. Thank you.
Hi, my name is Elian Carsenat, and the picture you see behind is called Chinese Sea. I invented the onomastic millefeuille as a visual representation of gender, biocultural, or ethnic diversity. This particular one is based on collaborative work with Dario Rodighiero and Eveline Wandl-Vogt. A visual translation of the pandemic prepared by Dario is available on the web. It is based on a huge amount of data, all publications related to COVID-19. And it looks like a night sky with galaxies and words, scientific subjects related to COVID-19, the authors who wrote the articles. What we did is we further clustered the articles into 30 different topics based on those keywords like hydroxychloroquine or bat. Then we use Namzor to classify the names of the authors by gender, nationality, or country of origin. And we found that on all 30 topics, most authors have Chinese names. The preeminence of Chinese scientists across all COVID-19 related subjects makes up the blue sea that you see here. Apart from China, all other countries seem to have focused their energy on one or two topics at most. This spike in green here, for example, it is the French, the scientists with French names, discussing if hydroxychloroquine is useful or not. So what do you see when you look at this picture? I see a mountainous shore and a Chinese sea. Enjoy the rest of the exhibition. Thank you.
Hello everybody, it is a pleasure to present my work at PIXELvienna. Because of the lockdown, the conference is streamed, and this recording takes place in Italy, from which I do smart working. My name is Dario Rodighiero, and I am a postdoctoral researcher at the Harvard University. I'm a member of the MetaLab, which is a unit that works at the intersection between arts, design, and knowledge. I present a work of data visualization titled Visually Reading the Pandemic. The intention is to present you a data visualization that shows a specific dimension of the pandemic, the scientific one. Why am I presenting at PIXELvienna? This is a very good question. Mainly, it is because the work of data visualization today depends on graphic design and video game technology. Graphic design, especially vector graphics, is the way in which the data are visually projected. Video games technology, on the contrary, is the way in which many visual elements can be managed in the internet browser. When you talk about data visualization, the works of Charles Minardi is one of the most cited. In this picture, you see the Napoleon's Russian campaign that was headed to Moscow. Charles Minard did a terrific work in translating an event into images. Usually, what I call visual translation is composed of two steps. The first step is about the measurement of the event, which means how the Napoleon's campaign is translated into data. The second step is about the way in which this data take a visual form. And what is specific of this visual form is the fact that the data are projected in many dimensions. If you take an accurate look at the map, you see different information. The number of Napoleon's troops, which are fewer and fewer as time passes, the distance they walked, the temperature at the bottom that is lower and lower as the time passes, the terrain and the geographical information. Neman River is on the left and Moscow is on the right, and the rivers works as geographical landmarks. The direction of the troops and the time is visible in the troops' flow. Of course, this is a really specific data visualization, but it is really good to summarize the dimensionality and the complexity of data visualization. But above all, data visualization is a method of understanding. Looking at the Charles Minard map, you have a better understanding of what the Napoleon's troops experienced. Especially looking at the temperature and the number of deaths given by the attenuation of the stream, you can truly imagine how that military campaign was difficult. Among the different types of data visualization, one is specifically interesting with respect to the current pandemic. This visualization is called network visualization. Networks are relational structures in which elements are related to each other. The network you see was created during the 30s by a social scientist called Jacob L. Moreno. Moreno called these networks sociograms. Sociograms were used to study friendship in a group of students. In the picture, you can see how B is friend of D, but D is friend only of G. On the contrary, C is a friend of E, and E is a friend of both C and F. Moreno was using this visual method to bring out the structure behind the human relations and gain a better understanding of social phenomena, like, in this case, the friendship. If you want, a good payoff for data visualization is let's make visible the invisible. It is interesting to notice that 1 century later, network visualizations are pretty similar, even though the complexity is higher and the way in which these networks are produced by personal computers, networks are still based on nodes and edges. The network visualization I created for the Digital Humanities Conference in 2014 represents around 1,000 speakers attending that conference. Each node is a speaker, and each relation is an interest in common. And the more two speakers have interests in common, the more they are close in the space. Again, this method is useful to read the social ties that exist in a community. The distant view provided by networks is useful to see the social structure that exists in daily life. But after this short introduction to data visualization and network visualization, let's see how this can be employed to understand the pandemic, or at least one dimension of the pandemic. A lot of visualizations were released during these months. The Johns Hopkins University's map is probably the most famous one. Collecting the data of infections around the world, they draw a map in which infections are visualized country by country in a visual style that recalls the Code Word, and movies like Doctor Strangelove, in which Stanley Kubrick shows us a control room with a similar visualization. In my humble opinion, I think that this map is most scaring rather than useful for a generic public. In addition, there is no doubt that this image is powerful and is shaping our perception of the pandemic. But the dimension of the pandemic I wanted to investigate is the scientific one. The reason is that scientists are the individuals in charge of finding a solution to the coronavirus, and people have a great expectation from them. On the left, this is the preparatory drawing of the Academy of Science and Fine Arts and the image of the school. Sébastien Leclerc dedicated this work to Louis XIV, who loved the representations of his power. The drawing shows the scientific community during the 17th century by describing their daily practices, which were composed of many activities: lecturing, discussing, drawing, writing, reading, and so on. On the right, you have the first number of the famous scientific journal Nature, which dates back to 1869. What is important to know is that today scientists validate their work through scientific articles, and these articles are a good way to understand the scientific work about a specific topic. This is the Widener Library in the campus of Harvard University. The library, which was built at the beginning of the century, has the goal to collect the most relevant texts to support education and research. However, with the coming of the internet, collections became digital. As a result, for studying the scientific activity of the coronavirus, it was used a digital collection distributed by Allen Institute for Artificial Intelligence. The collection counted 170,000 scientific articles on July 1st, published over 50 years. It is interesting to notice how coronavirus disease 19 has just a few months of literature. The dataset has been filtered on the current disease, indexed 20,000 articles and 80,000 scientists that published between December 2019 to July 2020. It is interesting to notice also that there is a production of more than 100 articles a day. But how to display the work of 80,000 scientists? If I have the answer straight to the question, I would say that it is not possible, or it is possible through an oversimplification of data. And there is no one single answer, as making a visualization is a performance that is high subjective. What I'm going to describe is my personal solution. The cartography of COVID-19 is a network visualization in which nodes represent scientists. The position of a scientist is given by their lexical similarity, calculated by a text analysis on articles. It means that the more two scientists write on the same subject, the more they are close in the visualization. Using text analysis also enabled to extract the most relevant keywords, which are displayed at two different levels, for distant reading and close reading. The cartography doesn't display all the 80,000 scientists, because such a number is too high for an interactive visualization. So, in this picture, you can see only those scientists who published at least 4 articles in the last 6 months. The scientific community has been so downsized to 66,000 scientists. The project is fully accessible at the address rodighiero.github.io/COVID-19. In the context of this conference, it is valuable to take a moment of the technology employed. Indeed, the standard technologies were not enough to visualize all the elements in the internet browser. Text, for example, is very demanding during the rendering. If we consider just the text, we can easily count around 10 million graphic elements. And this number is not manageable with standard web technologies. For example, HTML is completely obsolete in that sense. And also HTML5 that allows to draw in the canvas is obsolete as well. When I was looking for a solution, I finally ended up in PIXEJS, which some of you should know. PIXEJS is a JavaScript library which enables WebGL technology. Using Pixie, I was able to increase a lot the size of the network, keeping it interactive, especially text rendering speeded up by using bitmap rendering. The visualization is composed on 6 layers. Here you can see background, links, nodes, the elevation map, the distant keywords and the close keywords. These layers are brought together in a unique visualization, and now I will start a short demo. Okay. So thank you for listening. We switch to a live demo from the recorded presentation, just because I think it's better for you to understand what the visualization is. So to summarize, this network is a little bit unusual. It's describing 6,000 scientists working on COVID-19 out of 80,000. And so it's a small selection, but you will see it's big enough because this kind of network usually are smaller. And so the idea was to describe the work of this scientist. And the first operation when we create a visualization, at least when we create a network, is to create a space. So you have to imagine that we have to create a space between scientists, and to create such a space which is based on forces, we use one particular metric, which is the metric of lexical distance. This means for each scientist, we collect all the papers, so a lot of text, and then we run text analysis. Text analysis will allow us to select the most used keywords or words as you want, and then we can compare them between scientists. So basically, for each one, we are able to find the most relevant keyword. And once we have a list of the most relevant keywords for each scientist, we can create the forces to attract or push them away. So basically, the idea is that the more the two scientists have words in common, the more they are close in the map. So this map is created inspired by geographical mapping, geographical terrain representation, and mainly from the distant view, you see two objects. So you see words, and these words are the words that are shared between scholars. The size of the word is the relevancy, so how much they are used from these scientists compared to the whole community. And then you have a kind of elevation map. The elevation map, it shows the density. So you can really see the peaks in some part of the maps. And these two, let's say, affordances allow you to enter, to zoom in the map. So for example, if I am attracted by this part, which represent media, I can zoom and you see that there is a little peak, and by zooming, I start to show different data. So basically, when we finish the zooming, the words disappear to unveil a new level of detail of the map. And first, we see people, we see scientists. And what is interesting, for example, here I selected Yan Wang, and we can see on the left this panel with a few information about this scientist. We can see the best 20 words that described their work. And then we can even see the nationality, which is based on the algorithm provided by NAMSOR in France. And so we see that this person is working mostly with people of the same nationality. And we have even the publication here, but of course, this mapping is based on the last 6 months. So we have mostly papers just from 2020. And this is an example of use of the map. So we can see people. In yellow, we see co-authors, so basically collaborators that published in the same articles. And then we have a few keywords describing the work of them, the words they share together. So we see that this group mainly is based on as a work published on media, Python, Coherence, and I mean the selection of the words can be strange, but it is this kind of exploration. And otherwise, the other way to explore the map is by research. So we have a colleague, Vespignani, which is based in Boston. We can look at him. So we can look at him in the map. So Vespignani, Alessandro Vespignani is at the center. He's a professor at Northeastern University in Boston. And what is interesting is that this is the other affordance. So or you are attracted by a pics of the elevation map, by a specific word, you have then to zoom in. And like in the case of Alessandro Vespignani, in yellow, we can see his collaborators. And on the left, we can see the best words that describe his work. So we have China, mobility, travel, transmission, contact, distancing, tracing, and they are quite right, because Alessandro is working as epidemiologist, so he is interested in see how the virus spread all over the world. So this is the interface that is based on the web, and you see the working version in question and answer in the channel we have associated with this presentation. And just to conclude, I wanted to say that the visualization is open. It's a project that is going on. The code is open too. This means that you can fork the project and make all the modification you want. But basically, this is a new tool that is mixing in an unusual way the network visualization with text analysis, which are both in this case based on algorithms of artificial intelligence. But what is important for a generic public is that here you can see the work of a scientist to save us from the pandemic. So you have a different perception on the pandemic, and you can see the actors. They are working, the most active actors that are working in science in this moment, and you can even see the topics, which is very interesting for everybody. And with this demo, I thank you for listening to the panel. We will be available for the next 30 minutes in the channel of answer and question. So we will try to answer your question if you have some of one. And then I say you goodbye, and I wish you a very nice continuation and very nice day. Thank you.